Now we start into the world of logarithms. Logarithms were created because we had a problem. When we have something like x squared equals 4, we know that to undo the square, we square root both sides. And then we have x equals 2, plus or minus 2. But if we were to flip the problem and make it 2 to the x equals 4, well, we have an issue because what do you do to get rid of a 2 base when there's x in the exponent? It is the flipped situation. And so in this case, we know it's 2 because 2 to the power of 2, 2 squared is 4. But if we were to say 3 to the x equals 10, well, we want to run into problems. We know 3 squared equals 9, and 3 cubed equals 27. So we know the answer is going to be between 2 and 3. Logarithms help us solve this. And so, this is the way that you translate. A to the x equals y. This is exponential form. Is written as an exponent, equals number. There's a way to transform it into a logarithm. And the logarithm here would look like this. And so one thing to notice here, in both cases, the base stays, but the x and the y, they flip around when you translate them. So, for example, the way you would do this, you could take something like 2 cubed, that's 8, and you could transform that into a logarithm. That would be log, and we keep the base here, and then the 8 and the 3 will switch. Okay? And so we would read this as log base 2 of 8 is 3. Another one, like 5 cubed is 125. Well, we transform that. That would be log base 5 of 125 will be 3. The 125 and 3, they flip. Okay? And another one, like the square root of 4 equals 2. Now this is actually an exponent hidden. The square root, you might remember, you could write that as the 1/2 power. And then you could say log base 4 of 2 equals 1/2. Okay, so what good is this? Well, if you have the right tables or the right calculator, you would actually be able to calculate this. And this helps you solve problems. So for now, we're going to practice translating. And later, we're going to use logarithms to actually solve problems. There are actually two special ways to write logarithms, though. If you ever have log base 10 of something, if it's log base 10, we just don't even write the 10. So we just write log, and we know if there is no 10, then it's base 10. Or if there's no number, it's base 10. It's kind of like the square root. You know that there's kind of a 2 up there. You only start putting numbers there when it's different, like 3 or the 4th root. And so square root, you know it's a 2 already. Another one is the log base e of a number. You remember e. That's like 2.718 blah blah blah. Well, the way to write that is ln. When you see ln, you know it's base e. It has to do with e. And that's called the natural log. Natural because it happens so often. So, for example, like 10 to the b power equals 5, we would write that as log, and instead of writing base 10, we just skip it. Log base 5 equals b. Okay? And then also, like e to the 7th equals x. Well, we could write that as ln of x equals 7. And we can move in between these. So sometimes, like in your homework, they'll give you this, and they'll want you to translate it into that. So just a quick peek of like why this is useful. If you look on the left side here, 10 to the b equals 5. Well, when we translated it, log 5 equals b, this right here can actually be done on a calculator. So let me pull up a calculator here. And you'll see we have a log button right there. So I'll do 5 log, and my answer is 0.69, and I'll round to 9. So what that means is, if I do 10 to 0.699, I should get 5. And so that's how your calculator will answer these for you. Let's just double check that. It would be 10 to the power of 0.699. We should get about 5. And look at that. So we'll do that more later. I just wanted to show you that it is useful.